8 and number 10, these two problems I pulled from a couple old tests, and they are definitely some of the most missed problems that I have in trig equations. Because they have to do with cotangent and cosecant, and secant and tangent, and those are just harder to remember than cosine and sine. So with these, we're going to keep that same rule. We're going to keep the singlet, and we're going to substitute for the squared. Here we want to substitute for cotangent squared. If you don't have that memorized, that's okay. You do have sine squared plus cosine squared equals 1 memorized. So we can get cotangent squared and secant squared out of there. I'm going to divide to get cotangent squared. So I know cotangent squared is cosine over sine. So I need sine squared on the bottom. So what that gives me, that turns into 1. That turns into cotangent squared. And that turns into cosecant squared. What I want to substitute for here is cotangent squared. To get cotangent squared all by itself, I have to subtract 1. Cotangent squared is the same as cosecant squared minus 1. So that's what I'm going to drop in this equation for cotangent squared. And now, combine your like terms. Negative 1 minus 5 is negative 6. And we need to factor and solve. I'll use u for u again. So I'm going to say let u equal that middle term. So that means I need two numbers that multiply to negative 6 and add to 1. So it's going to be positive 3 and negative 2. So that means u equals negative 3 and u equals positive 2. And now we can substitute back in. So now that means that cosecant of x equals negative 3 and cosecant of x equals positive 2. Well, I don't like to think in cosecants, I'd rather think in sines. So I'm going to flip these fractions for myself. So I don't want you to say no solution here with sine is equal to negative 1/3. We can actually solve that. There is a value for that using our calculator. Since this is a no calculator unit, we're just going to say not on the unit circle. It's in the middle somewhere. And next, at some point in the near future, we'll talk about how to solve that. We've actually talked about how to solve that in geometry. You'd have done this to cancel those and use that button in your calculator signed to the negative 1 of negative 1/3 to find that answer. That, though, we don't have that memorized. We can't find that right now. We do know our sine is 1/2. Sine is 1/2 at our sixths. And sine is positive in quadrant 1, which would be pi over 6. And in quadrant 2, which would be 5 pi over 6. Just like we talked about on an earlier problem, those are not pi apart. So to get your general formula for all solutions, get all those coterminal angles, you're going to do plus 2 pi k on both. Again, keep your singlet, substitute for your squared. Even if you don't have 1 plus cotangent squared equals cosecant squared memorized, I don't blame you. Just get to it by dividing by sine squared. All right, number 9. Number 9 looks super messy, and it kind of is. With number 9, again, we're going to look for that singlet and keep it. And substitute for the square that's not like it. for this problem, the square that's not like it is that cosine squared. Now, I wrote this problem on purpose with that negative in front. When we substitute in for cosine squared, I really suggest just dropping it in parentheses. I've had students memorize how to substitute for negative cosine squared or solve for it and do it beautifully. I've had students really mess it up. So do what you got to do to get it right. I think you're going to want to put that negative in front of a set of parentheses. And now really until the last step, you've done all the trig you're going to do. Now you algebra. Carefully. Distribute the negative. I'm going to combine my like terms. I have two sine squareds. I have a positive one when I add those two together. And I'm going to bring over that 3 sine of x. When I bring it to this side of the equation, it's going to become negative. It doesn't have any like terms, so don't be tempted to try to combine it with the sine squareds or with the constants. All right, now we're multiplying the 2 and adding to negative 3. If U's help you, I will do them. So again, multiplying to positive 2, adding to negative 3. So negative 2 and negative 1, not another negative 2, goodness. That order doesn't matter. Out of my first 2, the way I have it written, I can take a U. Maybe you can take a 2U. Out of my second 2 terms, I'm going to take a negative 1 so that my signs match. So I have U minus 1 times 2U minus 1. So that means that U is equal to 1 and U is equal to 1/2. But remember, we're not solving for U, we're solving for sine of x. Well, we're solving for x. So we're going to come back here to substitute back in. If U equals 1, that means sine of x equals 1. And if U equals 1/2, that means sine of x equals 1/2. Again, these trig values get pretty repetitive. Sine is 1 at pi over 2. Sine is 1/2 at pi over 6. And 5 pi over 6. All right, number 10. Our last problem with tons of algebra. Here we have secant squared and tangent squared. On this problem, we don't have a singlet, so we can pick what we want to work with. I picked to work with tangent. I picked to work with tangent squared. Again, you don't have to have this one memorized. You just have to know how to get there. I'm going to work with tangent squared. I know tangent squared is sine over cosine. That means I need to divide by cosine squared to get there. Sine squared over cosine squared is tangent squared. Cosine over cosine squared is 1. 1 over cosine squared is secant squared. There's my equation. If I want to get rid of secant squared, I can drop in instead tangent squared plus 1. Or 1 plus tangent squared, if that's what you would like. That order does not matter. again, there was no singlet here, so we could pick what we worked with. And now algebra for a bit. 2 tangent squared plus 2 minus tangent squared minus 3. Combine your like terms. I have 2 tangent squared and I'm subtracting 1, so that's just a tangent squared. I have 2 minus 3 is negative 1. There are 2 ways you can go from here. You can recognize this as a difference of squares and factor it. I dig that. Or you can directly solve. So you can add the 1 over and get tangent squared of x equals 1. And take the square root. Just have to remember when you force that square root, you need that plus and minus. You don't have to worry about remembering that if you factor the difference of squares. That plus and minus is built in. Okay, so what do I have? Well, I have tangent of x equals 1 and negative 1. So let's see, and I have plus minus, so I know I'm going to need 4 solutions. Tangent is 1 in all of our fourths, well, or negative 1. Tangent is positive in our first quadrant and in the third quadrant. Third quadrant is 5 pi over 4. Tangent is negative 1 in our second quadrant, which is 3 pi over 4, and our fourth quadrant, which is 7 pi over 4. It really seems like you should be able to write a nice equation for these all together, but it's just not doable. You have to write 2. Pi over 4, if you draw that picture, is a cross unit circle from 5 pi over 4. So pi over 4 plus pi k takes care of those 2. 3 pi over 4 is across the unit circle from 7 pi over 4. So that takes care of this. And that is really all the algebra. The next section is quite a few guess and tests for you to enjoy.